Hiya, Seven. It's good to be back doing some more recordings with you. Hope you're all staying safe while you're at home. We're going to continue on with our linear relationships topic. So I think last time we were playing battleships. We're going to go look at the Cartesian plane. And we're going to start off with a bit of a pun. So, have you heard of a homophone? It's when two words sound the same. When two words sound the same. Two words that sound the same. What is an example of two words that sound the same? I always like when you read a book and read, like you might find down by a riverbank. That's a homophone. And then a homonym is when two words have the same meaning. And then I think there's also one where two words are spelt the same but have different meanings, like read and read. Anyway, the point I'm trying to make is, here I have two words that are spelt the same but are completely different. I have axes and axes, except it's the other way around. Here's the joke. I said create some axes, not axes. So this is the plural of axe, and this is the plural of axis. And they're the same word. Isn't that terrifying? Well, they're different words, but they're spelt the same. How can two words have the same spelling? Don't think about it. It's just English. It's just English. What are you going to do? Anyway, you're going to write down Cartesian plane. And let's continue. All puns aside. Whoa. Negative numbers? Negative numbers? Whose idea was that? Who's put negative numbers in here? Who's gone and done that? The syllabus writers? Yeah, it was them. But also it's your fault. You went and learnt about negative numbers and now I have to use them. The axes on the number grid can be extended to include negative integers as shown. So we had 1, 2, 3, 4, but -1, -2, -3, -4. And then 1, 2, 3, 4, -1, -2, -3, -4. So we have our negative numbers. You can go ahead, draw some nice little axes. Don't forget the numbers, the words origin, x-axis, and y-axis. Another name for the number plane is the Cartesian plane. Cartesian plane, named after René Descartes. Ooh, how do I spell that? I think it might be that, or maybe that. And then, how do you spell Descartes? Well, it's very simple, with a whole lot of extra letters. Because maybe it's French, and, get a lot of extra letters if you write something in French. More letters than you say, for sure. What is René Descartes famous for? I guess Cartesian plane's a good one. A bit of a philosopher. You might have heard, I think, therefore I am. Or maybe you heard it in Latin, like cogito ergo sum. Something like that. Anyway, that was where he got to with his philosophical ideas. The only thing he could be sure of was that he was thinking, therefore he must be something. Anyway, you've written this down, I've stalled for enough, we're good to go. X coordinate shows the move to the left or right. X goes first because X is alphabetically superior. That means it's first in the alphabet compared to Y. Y goes next. It shows you up, positive, and down, negative. One more thing. I'm going to make you write this. 1, 2, 3, 4. You can go ahead and number our quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. The numbering does make sense. It's where everything is positive, it's 1, and then, who am I kidding, doesn't make sense. The idea is that we start on this line and we go anti-clockwise because that's the mathematical convention. But 1, 2, 3, 4. Go ahead and write them down. And then let's go. Okay, I'm going to read this and you won't have to write any of it. The origin is the point where the two axes intersect. There it is, you know that. It divides the plane into 4 quadrants. Are all the quadrants the same size? Well, they're all infinite, so how do you measure that? But certainly in some sense are the same size. We number the quadrants starting with the quadrant in which they're both positive That's the quadrant number 1, and we go anti-clockwise, so 1, 2, 3, 4. You already wrote that down on your last slide, so you don't need to write this again. See how we cheated the system there? That's pretty good. The reason why we do this is that there are some things in maths that we want to describe. One of the things that we might want to describe would be a circle. And a really, really nice way of describing a circle starts here and goes that way. So we say this is where it starts. We say this is where it starts. 1, 2, 3, 4, and it goes that way. And that is the nicest way we have of describing our circles. And that's to do with pi, as you might have guessed. We do it that way. And a bit of triangle stuff. When could we do that? We can definitely do that in year 11. Maybe at the end of year 10 if you ask really nicely. I'll show you that one. All right, let's go. Okay, here we have some points plotted. Check out this one. X goes first, so starting from 0, 0, we always start from 0, 0. We went 3, negative 3, so we went 3 left, 1, 2, 3. And then we went up 4, 1, 2, 3, 4. We got there. This one over here, we went 4 left and then 1 down. And this one over here, we just went 0 left or right, we stayed where we are, and went 4 down. I'm going to do some highlighting. This highlighting is in green. That's because this part is optional. Horizontal direction first, and then vertical direction. It's just a convention. We have to pick one, we pick this one. Ordered pair tells you order is important. X coordinate is first and Y coordinate is second. So it's X coordinate, then Y coordinate. Coordinates of origin are 0, 0. We've done all that. You've written all this down at some point. Maybe. If you think that we haven't, then you should definitely write the things down that you're missing. You might need to pause the video because I am going onwards. Okay, example. Write the coordinates of each of the points A to H shown in the Cartesian plane. All right. Example means I do it. What do I need you to do? I need you to pay very close attention and maybe watch on 2 times speed if you're absolutely sure you know this. So I found A. A is 3 on the x-axis and 4 on the y-axis, so it is 3, 4. See how I go my big letter, then straight to an open bracket? B, 0 on the x-axis, did it go left or right? 3 on the y-axis. That's the proper setting out. Okay. C, negative 5 on the x-axis, 5 on the y-axis. X always goes first. Let's go find D. That's 4 and 0. E, negative 2 and 0. Negative 2 on the x, 0 on the y. F. F is 5 on the x, negative 2 on the y, 5 on the x, negative 2 on the y. G. G is negative, G is 0 on x and negative 1 on the y-axis. And then lastly, H. That's negative 3 on the x-axis and negative 4. Negative 3 and then negative 4. Always horizontal axis first. And then negative 4 on the y-axis. For part B, I'll answer in red. State the quadrant in which each point is located. So A is in quadrant 1. I've never thought about this, but what quadrant is B in? Is it in the first quadrant? Are x and y positive? No. No. To be in quadrant 1, the values need to be positive. 0 is not a positive number. So for B, technically, I believe the answer is neither, but I would accept 1 and 2. So you could write 1 and 2. If you want, I would accept that, but I would also accept neither if you want to be really technically correct. C is in quadrant 2. I might just label the quadrants here for us. And then D, we'll just say 1 and 4. I think it's nicer to say where it is. That actually describes where it is, rather than just saying neither, which tells us nothing. E is between 2 and 3. F is firmly in quadrant 4. G is between 3 and 4. And H is just chilling in quadrant 3. So I have a 1, 2, a 3, a 4, a 1, 2, a 2, 3, a 3, 4, and a 4, 1. Every combination is there. Okay, there is some work here. I think we might try and get that posted. And I think I'm going to end the video here. The next video is going to be a little bit longer, so sorry about that. It just has to be a little bit longer. We've got a lot of fun stuff to do. That's when I actually start learning something new. Okay, good luck, Year 7. Stay safe.